2020 Skywarn Spotter training class and the first ever Storm Spotter training class in a virtual world Sansar. Hello. So this is a class that everyone here will earn basic Storm Spotter certification, and the only requirement is that you are here from start to finish. So I'm going to go ahead and do a quick bit of attendance here. So I'm going to take a screenshot of who is here right now. I'll get that snippet out of my stream. All right, so it is, whoops, one more time. Just doing a quick attendance capture here. So much easier to take attendance in a virtual world than it is in real life. Boom, attendance is done. All right, everybody that's here is marked here. All right, so we'll go ahead and get started. So the only catch is in order to get your certificate, you're gonna have to be here at the end of the event as well. So that way I'm gonna do the same thing and match it up to make sure that you've been here for the entire event. So other than that, we'll get started. So a few disclaimers. At first, I have to remember that there's a 3-second delay with the slideshow. So of course, all the images are used with permission, blah, blah, blah. Okay, the blah, blah, blah is the fine print. Okay, so the goals of a Skywarn spotter. So everybody here, remember the very first thing that you always need to think of when you are outside and you're looking face-to-face with severe weather is safety. Always think of yourself first as keeping yourself safe. Don't ever put yourself in danger and say, oh, I need to run out and in the path of this tornado. No, worry about yourself, keep yourself safe. So you want to be the eyes on the ground with the National Weather Service. What you're seeing on the ground, you are going to be able to relay to your National Weather Service forecast office. I'm going to give you a website here in a few minutes, and you'll be able to get your local National Weather Service office phone number, so then you could call in your reports from there. So what we're going to cover here tonight is why do we need storm spotters, what you need to report, what the severe weather climatology is, severe thunderstorm types, severe thunderstorm components, lookalikes, and then I'm going to add in a few other little things, followed up by a little trip to our simulator. So the National Weather Service is a part of NOAA. Many of you have heard of NOAA, the National Oceanic and Atmospheric Administration. It's a department within the U.S. Department of Commerce. And there's the mission right there, which is also stated on the website weather.gov. So National Weather Service forecast offices are spread throughout the United States of America, and it's zoned off by counties. As seen in this map, I'm sure you can find your area, and as long as you're in the United States, there is a National Weather Service forecast office that covers your area. And this just shows there's one National Weather Service right here in the center where the star is, and they cover multiple counties. So therefore, the more eyes on the ground, the better, just to confirm what is going on the ground. So there's many different sources that you can go to obtain weather information. My preferred one is weather.gov, not to be confused with weather.com, which is the Weather Channel. I've been told from them that it was sunny and clear when we had a tornado on the ground. I don't go by weather.com, always weather.gov. It's accessible through mobile phones, computers, tablets, you name it. Weather.gov, you can bookmark that in your phone like right now or right after this event. Another source is NOAA Weather Radio, which you can get more information weather.gov/NWR, or you can pull one up on Amazon or get it at your local Walmart, wherever. Everybody that's an electronics store pretty much has one somewhere. You tune it into the right channels for your area. You'll hear 24/7 broadcasts of the forecasts, and real-time instant watches and warnings will be issued through that before you even hear it on television. And that's the other sources as well, is your cable, satellite, commercial television, or radio outlets. Those will also give you your weather information as well as your local emergency management. So like I said, weather.gov, that's where I go to. So let's pull that slide up. So if you go to weather.gov and you go to your local area, it will give you a small map of your local area showing county by county, and it will color code watches, warnings that are currently issued, such as over here in the reds, we got a severe thunderstorm warning, and then over here in the oranges, you have a tornado watch that's issued. So you can click on each one of those.
Sir, can you hear us?
And when you click on your area, you're going to pull up this page. And so this page will give you up here where it says forecast at a glance. That's, of course, the thumbnails that shows you what to expect in a short glance. And then on the left side in the column, in the red, you'll get all of your watches, warnings currently that are issued for your area, as well as a detailed 7-day outlook. And on the right side, you have your current conditions, as well as your current Doppler radar and satellite images. And I've already covered the NOAA weather radio. So like I said, you can buy one looks like that or something similar at your local electronics store or Amazon.com. So products is just what would show up, such as like on the National Weather Service website. So when you're on the National Weather Service website, you could look at the hazardous weather outlook, which is a summary of potentially dangerous weather situations that are coming up for the next 7 days. Then you have your zone forecast, which is a general 7-day forecast of your specific county. Then you got the short-term forecast, which is up to 6 hours in advance. And then they also give you the watches, warnings, and severe weather statements. Severe weather statement is usually the follow-up for watches or warnings as they're issued, such as if there's a severe thunderstorm watch issued, they may follow it up with a weather statement, just saying that more information about what's going on and what to expect in the near future, that the watch hasn't been canceled and whatnot. So we'll move on a little bit into some more technical stuff. So don't have to worry about this quite so much. We're going to cover this briefly, and this is for those that actually want to get out there and actually go chase tornadoes, and you're going to be looking at a lot of Doppler. So with all those fancy gadgets, why does the National Weather Service need spotters? So we need spotters due to radar limitations, such as bad you get resolution issues, the distances of the storm versus the radar. Think of it like a lot of us here are artists and whatnot, so we're familiar with working with pixels in our textures. So the way a radar works is it's like a ping pong machine. So the radar is going to send out this packet of data, and it's going to wait to see if it hears it come back to the radar screen. So the way it's going to come back is it'll hit the droplet of rain or moisture in the air, and it'll come back to the radar. And what happens is the further away the storm is, the lower resolution of a signal it's going to get. So you're going to get pixelated images on your radar if it's further away. So it gets a little bit harder to tell if you're looking at a hook echo or just severe supercell, or it gets kind of hard to tell when you're looking at it from a far distance. And then the other thing is weak tornadoes. Not all tornadoes are going to show up on radar. So storm spotters can help be the eyes on the ground, and also you can also give the real-time verification as well. So, like if I see something on radar, I can say, hey, so-and-so, can you confirm if this is a tornado on the ground or not? And then you can come back and say, hey, yes, that tornado is on the ground. And then the warning can be issued to the community, storm spotter observed a tornado on the ground versus radar indicated tornado. So as a citizen, you're going to take a human being observing that tornado on the ground way more serious than you would a computer indicating a tornado. I mean, that's just human nature. So here's a good example of the radar beam versus the curvature of the Earth. So this really shows that the bottom of the storm, when it's closer to the radar, you get a pretty good view of it on the radar, versus when the storm is further out, the beam is going to miss the bottom portion of the storm and pretty much give you just the upper atmosphere coverage and show you what's going on higher up in the storm. So you may miss any like small minor rotation and heavier precipitation down towards the bottom of the cell. Another example is the beam width. So this is like I was saying with pixels. So the closer the storm is, the better resolution you're going to get. It's going to come back with smaller pixels on the screen. So I could make out a better image in my head of what I'm looking at versus further away, it's going to be larger pixels, which will make a lot of sense once we get further in here. And then the other thing is the rotation as well. Close up, I can tell what's going on. I can see when we got rotation in that storm. But further away, it's going to come back as 1 pixel. I'm not going to be able to tell what's coming towards me or what's going away from me when it's all 1 pixel. Another thing is radar blockage, when you got a storm blocking the signal. So over here, you see DSM. That's where the Doppler radar is right here. And you see storm B here is a pretty strong cell. But behind it, you have a storm A, which, if you look on the image on the right, they're pretty much the same strength. But the image on the left, it doesn't look quite as strong because, again, you're playing ping pong, so that packet gets sent out, hits the first storm, and comes back. And there's not enough making their ways through that first cell to hit that second cell, and then make their way back through that first storm to come back to the radar. Even the packets that hit that first storm and try coming back may be reflected off into space when they make their way through storm B again. So it's always good to have that extra eyes on the ground. And then here's just another image of it. In the center of the image is the Doppler radar on the left. And you can see again up here on the top of the image that the one on the left, you can't really tell that it's as severe as it really is. And that's also where a lot of Doppler radar networks come in handy as well, because you can utilize other Doppler radars from other areas as well to kind of compare. So if I'm in the Dallas, Texas area, and I think that a storm cell is being blocked, I can hop over to Houston's radar, or vice versa. And that way you can get a little bit better judgment on what's coming at you. And then here's what I was talking about with pixels, pixelated images from a distance. So this is the same exact storm, same exact time. So this radar on the left is about right where my mouse is here, whereas the radar on the left, it's probably way over here. So you can see the closer the storm is, you get a much better reading versus being further away from the radar. It gets a lot more pixelated. Again, this is like an example, Dallas radar versus Houston radar. So you want to definitely make sure you're tuned into the closest one you can, but sometimes that's just not enough. So it's always good to have the eyes on the ground. So the next one is how to look at hook echo, which is where tornadoes are formed in the radar. So if you want to see how to tell where a tornado is, right here is it. So you have your cell here. A lot of people are like, oh, look at all these pinks and darker colors over here. That must be where the main bad part of the storm is. When in all actuality, it's right in here. I'm trying to go a little slow so that the lag can keep up with what I'm saying here. So again, same cell on the right. You're looking at this curvature in the radar signature here. And so you follow that in, and right about where that arrow is pointing is where you're going to have that tornado, because that's where you're getting all that rotation. So here's another image of it. On the left, there's the precipitation image of the radar. Right where that arrow is pointing right here is where you're going to have a tornado signature in that hook echo. Now on the right side is what we call the velocity radar. So this is going to show your wind directions going toward and away from the radar based on color codes. So your greens are going to be going away from the radar, and your reds are going to be going towards the radar. So right here, whoops, hitting the slides here. So right here, it's a little hard to see. I know you can hit F4 if you need to zoom in a little bit. So right here, you notice there's this green dot right in the center of this red. So that indicates that there is activity going away from and towards the radar right inside of here. So that indicates that there's some rotation going on in the storm. Now, is it a tornado? Well, we don't know for sure just based on the radar. But there's good indication that there's a tornado there. But it would be really good to have a set of eyes on the ground to confirm that. Again, velocity imagery on the right, precipitation image on the left. There's your hook echo on top. And it's pretty dominant in both those images. Now, the lower image, it's a little bit harder to see. And in fact, you might almost miss it in the precipitation image, whereas in the velocity, you can notice that there is a pretty decent rotation going on in that velocity image. And here's just another one. And this next one here is a good example of the EF5 tornado that went through Moore, Oklahoma a few years back. And this was a very, very large, damaging, destructive tornado. It was EF5, which is the highest scale you can get. And right here where that triangle is marking is where your tornado was. And you can just see the storm, how it has that rotation in there. And here it is. And the next slide here is the velocity. So again, you can see exactly what I'm saying with the wind direction. There's a lot of video on YouTube about that one. All right, so here I'm going to show you a quick video animation so you can see actual hook echoes taking place within the radar images. You can compare the two from the precipitation on the left and the velocity on the right.
Is that the EF5?
Yes. Yep, you can see when it goes right over the radar too. You can really see it on the right side there with the velocity. You can see that almost in real time as that wind and direction flow just gets that perfect formation there. So move on. So our National Weather Service radar is in real time. Well, like I said, it has to work like ping pong. So in this globe, this will be found at every National Weather Service forecast office in the United States. So in that globe is an antenna that's spinning around very slow. And what it's doing is it's sending that packet. It's sending like this invisible ping pong ball out of it. It's throwing it towards the sky. And it's just sitting there waiting to listen to see if that ping pong ball is going to come back at it. And it'll measure how fast that comes back at it. It'll measure how much of it comes back at it. And that measures the speed, the mass of the precipitation, the direction that it's going. All that data it can gather based on the received packet of it going out. Now, what it does is it's like a revolving antenna. So what it's doing is it's sending a packet, listening to receive it. And then it's slowly turning as it's doing that. And it takes about 10 minutes to make a full 360-degree turn with that packet or with that signal. So once it makes the full 360 degrees, then it creates that into an image. And that's what you see on the radar. And that's why you see frame, 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 frame. And generally, the frames are about 10 minutes apart from each other. So are they in real time? Kind of, sort of, but it could be within 10 minutes. So it's best not to wait until you see it directly on top of you on radar if you need to take cover, So we're going to cover a little bit more now of some knowledge. As a spotter, you're going to definitely want to know the differences between a watch and a warning. So a watch is when conditions are favorable for the development of severe weather. So that doesn't mean that it's necessarily happening right now, but the conditions are favorable for the severe weather to develop. Whereas a warning means that severe weather is imminent or occurring right now. Take shelter now. Do not wait. It's happening. Don't wait till you see or hear it. That means that it is currently active, a spotter or radar indicated that severe weather is happening. And the same thing goes with tornado warnings. When a tornado warning is issued, that means that a tornado is happening or it's imminent. Take shelter immediately. Whereas a tornado watch means that the conditions are favorable for it, and stay tuned to media sources to hear if there's anything that comes out of that storm that you need to take shelter for. So again, like I said, tornado, we all know tornado is a lowering of the cloud that touches the ground. So when a tornado warning is issued, a tornado is occurring, verified funnel is reported, and it is on the ground. Or the radar could indicate that there's thunderstorm capable of producing a tornado by indicating what we've already seen in those hook echoes as well. Another thing that gets issued is severe thunderstorm warnings. I'm sure most of us that live where there's storms have heard the sirens or the alarms go off on your phone for a severe thunderstorm warning. So if severe thunderstorm warning is issued when winds are greater than 58 miles per hour, or you have a possibility of 3/4 of an inch or larger hail. So those winds are going to be able to be strong enough to knock down some strong tree limbs and power lines, damage weak structures. It's just a cool image of different severe storms and what they can do. And then the other thing is flash flood warning. So a flash flood warning is when there's a rapid rise of water where the water flows out of the river or pond banks, and it causes property damage or life-threatening conditions. Also, when there's approximately 6 inches or more of water flowing over a bridge, over the edges of the bridge, and any amount of water that comes in contact with or flowing into a structure, such as a house or something. Now, this does not count if it's going into a basement. A basement is below the ground level, so this is only if it's going into the main level of the building. Then the other flash flood warning criteria is 3 feet or more of ponded water that poses a threat to life or property. So keep a lookout for flooding as well, and they do like flooding reports. So different spotter groups. So there's different groups, such as just us as just citizens. And then the other spotter groups are your county emergency management, law enforcement, fire departments, National Weather Service spotters, advanced spotters, the ham radio operators, also known as amateur radio operators, as well as others such as media and storm chasers, not to be confused with storm spotters. And I guess I can mention too, storm spotter and storm chaser. Anybody know the difference?
I thought they were the same thing.
I think doesn't a spotter, a spotter is scientifically educated, and a chaser just basically chases storms for entertainment, right?
Very, very close. Yes. Yes. So storm chasers, yes, a lot of them are scientists. A lot of them are doing it for scientific reasons, but at the same time, they chase the storm from start to finish. They put themselves in the paths, whereas a storm spotter generally stays within their assigned area, within like one National Weather Service area or their home location, like home base per se. So like me, I stay within 2 counties. So what I'll do is I'll position myself. I'll try to get southeast of the storm, which is considered a safe spot, and then I'll track the storm as it's going through. Once the storm exits my area, then I'm no longer following the storm. I'm then giving reports back for any storm damage that occurred, or if there was a tornado touchdown, I may switch over to disaster recovery mode just to help try to rescue people. Whereas a storm chaser is going to chase that storm from start to finish. A lot of times, a lot of them will even put themselves in the path of danger, which is just ridiculous. You don't need to do that, especially in today's day and age. We know what's going on there. Just spot it from a distance where you're safe. Don't put yourself in line of danger. And always spot as a group. Don't just go by yourself. So yeah, spotter activation. So group spotters, law enforcement, areas races, which is ham radio groups, fire departments, individual spotters, which is just normal citizens. You're all part of the spotter activation. So when you go to the website, you can even see a spotter activation report summary that'll say spotter activation may be needed tonight, or no spotter activation will be necessary. So that way you get an idea of, are they going to be calling for help with spotting these storms. Now, if there's a severe storm and you see something, report it. So the best way to do it, go to weather.gov, look up your local National Weather Service office and get the phone number and call directly in. Granted, you can go through your local law enforcement agency, you can go through your local media, who will then both relay your information to the National Weather Service forecast office, but it's always best as a trained spotter, you can go directly to the source by going to the National Weather Service website, go to the, you can call it in, or you can look up the eSpotter information and sign up through eSpotter, which is also on the National Weather Service website. Just search for eSpotter. So effective spotter reports. So best way to do it is call your National Weather Service office by the phone or amateur radio, and also the eSpotter network, like I said, and state your report. You give your identity that you're a trained spotter, give your exact location, and your location relative to the event. State the start and end time of the event, or if it's occurring right now, and give the best description possible. Also, do not assume that if a warning is issued that the National Weather Service knows for sure that a weather event is occurring. If you see a tornado, funnel cloud, waltz cloud with rotation, report it. If you have strong wind damage, enough to knock down entire tree limbs, power lines, block roads, report it. So estimating wind speeds is something else that you want to really look into, is figuring out what wind speeds you're looking at. It's kind of hard to estimate what speed the wind is going. You can't see the wind. So best way to estimate wind speeds is to look at your surroundings. So if you have large branches in motion and that's about it, generally about 30 miles an hour winds. Now when the whole tree goes in motion, you're looking at about 32 to 38 miles per hour. And then when you start getting the twigs to break off and the wind starts making it really hard to walk, you're probably upwards to around 40 to 55 mile an hour winds. And then once you get damage to the chimneys and TV antennas, large branches and stuff like it says there, you're looking at 55 to 72. That's criteria. You could go ahead and report that in. 73 to 112, remove shingles, windows start breaking, trailer houses flip over, trees get uprooted. Yeah, you're definitely reporting that. And 13 mile an hour and above, tornadic wind speeds, hurricane wind speeds, roofs get torn off, weak structures, buildings, trailers destroyed, and yeah, it's just mass chaos at that point. One thing to keep in mind, though, when you're estimating the wind speeds is what they call the set effect. So anybody that's an adrenaline junkie, you know what's going on here. So it's the stress, excitement, and tension. So when you're looking at that storm and you got all that wind hitting you and you got hail and rain and lightning coming at you from every direction and maybe even a tornado, your excitement is going, your adrenaline is pumping. And so it's really, really easy. Even as an advanced spotter, meteorologist, everybody knows this effect. And it's the set effect. It's your stress, excitement, and tension all working together to make you sort of overestimate what's really happening. So what may seem like 60 mile an hour winds may really only be 40 mile an hour winds, which may even seem less on a clear sunny day when you just have a lot of wind. But because you add in all those other factors, you may think, oh my God, this is really, really serious. I got to report it. So when you go to make a report like that, just slow down for a minute and think about the set effect and be like, okay, wait a minute. Are these trees really breaking off? Is this really going to be something that they're going to be interested in? Generally, if it's less than 55 miles an hour, I usually don't even bother because, yeah, they know that there's severe weather, and that's part of a severe thunderstorm is just to have a lot of wind. Now, if it goes over 55, you're going to start getting into a lot of, property damage and whatnot. So, yeah, go ahead and report that. And then the other thing you want to think of is hail as well. So hailstones, anything 3/4 of an inch or greater, they want to report. So best way to do it, go out there, grab a piece of hail and measure it. Now, if it's like pea-size hail, they don't really want to get a report, hey, I got a couple of pieces of pea-size hail. However, if it's enough to cover the entire ground and it looks like it just snowed outside in the middle of the summer, go ahead and report that as pea-size hail. However, it's enough to cover the entire surface of the ground. That would be worth reporting. And then how to report that? A lot of people go revert to the marble size. Marbles are all different sizes. Use your currency, use your change. Hold up a dime to it and say, yeah, this is about dime size. This is about penny size. Don't go to marble size. That doesn't work. Golf ball size works. Softball size works, as you can see in the next slide here. Quarter size, half dollar size, golf ball size, tennis ball size. That all works. Don't do marble size. So, pop quiz. Everybody ready? Let's see if anybody knows this one. What size hail do you report when there's many different sizes of hail? Should you report the smallest, the average, or the majority of the hail that you have, or should you report the largest hail size? Anybody?
Largest?
Yep, exactly. Go out there, look for the largest pieces of hail that you can find. Give that a measurement. Report that in. Because it doesn't matter if it's the average or majority, because that's going to cause the most damage. Report that. How about this one? How do you measure an oblong hailstone? Shortest length, average length, or longest length? Anyone?
I'd say
what do you think,
longest.
Longest?
I would say average.
Average? It's the longest length.
Oh, I was wrong.
So find the longest part of that hailstone. Give that a measurement. Report it. So how do you report it? So call your National Weather Service office. Best way to do it? Hi, I'm so-and-so. I'm a trained spotter, and I would like to report approximately golf ball size hail at the corner of Milk Boulevard and Herring Avenue in Waco at 3:15 p.m. So that covers your time, location, magnitude, and whether it's measured or estimated. Don't call in and say, yeah, I just had big hail over here. I'm by Waco. It was a few minutes ago. No, don't do that. They're gonna look at the phone and say, yeah, you're a moron, and hang up on. So, storm damage. After the storm passes, go ahead and report it, especially if it's that bad. I mean, even if a tornado warning wasn't issued, it could have been a microburst, which is a tornadic wind speed straight line wind gust. Or it could have actually been a tornado and it just wasn't taken into account or consideration at the time. And maybe based on the damage can be ruled out as, yes, there was a tornado touchdown here. Another thing to report is urban flooding, enough to cover the roadways, as well as rural flooding, enough to damage crops. Also report heavy water rising, such as if it goes over the bridges, over roadways, parking lots, and be careful of flash flooding. 3 to 6 inches is enough to wash most vehicles off the roadway, especially when you got flash flooding. It's moving pretty quick. So it's very easy for you to lose traction and just wash your vehicle right off the road. Doesn't matter if you have four-wheel drive, if your 4 tires lose traction. And another image, good example of flash flooding, high water rising under that bridge. I wouldn't want to pass over that. Another thing to report, heavy snowfall and ice amounts. Ice accumulation enough to break large tree branches, take down power lines. Yeah. Reporting winds. A little bit more on that before we continue. So you observe a thunderstorm wind of 50 miles per hour at your house just about every year. And that's enough, like I said, to break twigs and branches. 70 miles an hour and above, yeah, you definitely want to report that. Like I said, I usually do about 55 and more. So that covers damaging roofs, notable tree damage, uprooting full trees, and anything like 90 and above is going to be tornadic wind speeds. Definitely report that. So you may want to turn your volume down just a tad on your world audio, and this is going to show you some video from the National Weather Service office in Texas.
So let's go a little bit higher now. All right, so that's getting close to the threshold of severe. You have some twigs and branches starting to break off. It's hard to see, the end of the driveway at this. Here's another video. This is a little over 60 miles per hour. That was actually from a downburst in the summertime. I believe it was filmed in Irving, Texas there, and the top half of a tree came out as that went through. All right, now this is getting into some pretty intense straight line winds now. And that right there is getting, almost, it is hurricane force winds, almost no visibility. At some point in the video, you saw the tree branch fly across the screen. Back it up if you missed it. And you notice that the trees that were out there were struggling to stand. And that seems to be about as high as winds can get most of the time. Or is it? Let's see what about 110 miles per hour might look like. So that video was filmed during Hurricane Michael, which was actually a Category 5 hurricane that made landfall in Florida in October of 2018. I don't think they were right in the Category 5 winds, but it was pretty intense. And notice if you were standing in that kind of wind, well, you wouldn't be standing for very long. There's large debris blowing through. So now you have kind of a visual idea of what these winds look like. But
Okay. So, yeah, just another slide here that just shows a few pictures. And I believe this is the Texas office in the center there. So yeah, that video was made by one of the meteorologists at the, I want to say, Houston forecast office. So it was pretty cool to see the different wind speeds and what to look at. So again, when you're reporting, if you report wind, so again, hi, my name is blah, blah, blah. I'm a trained spotter and would like to report numerous 1 to 3 inch in diameter tree limbs broken. No other damages noted right now. I'm located 5 miles north of Axel on 317, and this happened around 3:45 p.m. I've also tweeted a photo to you. So that gives you the time, location, magnitude, whether it's measured or estimated, as well as the damage. And this also includes a photo because a lot of times wind is harder to decipher or estimate. So this way it also gives them a little bit of reference as well. With today's digital age, just grab a photo with your phone, send it in through social media. You got Twitter, Facebook, Instagram, whatever. National Weather Service is there. So go ahead and after this class, if you want to like them, follow them, whatever you do on whatever social platform you got, then you can just send them a picture or video of something if something's going on, and then that way that gives a little more reference. Don't call in and say, yeah, I just had crazy winds over here. I'm by Axel. I thought my roof was going to fly off. No. And then also, there's a few things you don't want to report that a lot of people call in and report. So don't call in and report what you see on radar. Okay? There's meteorologists looking at radar. They know what's there. You don't have to call in and say, hey, look at that little spiral going on the radar. No, you don't have to do that. It's fine to call in and say, hey, I got rotation in this wall cloud, but don't call in and say I got something weird on radar. Heavy rainfall? No, don't worry about it unless it's flash flooding. And scary looking clouds? No. Lightning? No, unless it's causing property damage or life threatening. But by that point, you should be calling 911, not the National Weather Service. So lightning, what am I looking at? Lots of lightning. Should I report it? No, unless it's causing life-threatening conditions, which, like I said, call 911. What am I looking at? A supercell with a wall cloud right there. There you go. Should I report the wall cloud? Is the rotation? Is it organized? Report it. Generally, I don't always report a wall cloud if there's no rotation. We'll get into wall clouds a little bit more here in the slides. Supercell on radar. Should you report it? No, it's on radar. Unless you're witnessing it in person, don't report it. So we covered good, bad reports. Just keep that in mind. Give your locations, give what's going on, give as much detail as you can. Don't just say, I'm on this road and there's some wind. Might want to turn your audio down for this one. Not too bad, I guess.
Think to yourself, will this be severe criteria winds, and should these be reported to us at the Weather Service? So again, here's the question. How strong are these winds? Are they severe? These winds are maybe 35 to 40 mile per hour tops, not even close to severe. And should you report this? No. We do not need to know winds of only 35 to 40. We generally want it to be 50 or higher, or there's significant wind damage. But of course, you should always monitor for intensification. Is this hail severe? Only one way to find out. Measure it after it has stopped falling. Should you report it? If it's greater than 3/4 of an inch, which eyeballing it here probably is. What's that? This is a funnel cloud. It's underneath a wall cloud in a rain-free base. Got a nice smooth appearance to it on there. Should you report that? Yes, absolutely. This here, though, is just a scud cloud. It's in front of a downdraft portion of the storm, more ragged in appearance, and that does not need to be reported. And then finally, I hope we can identify that this is a tornado. You have foam, large debris cloud underneath it here, and absolutely report that to us.
Okay, so let's backtrack for 1 second. Go back to that scud cloud. Does anybody know what a scud cloud is? Anybody?
From what I gather, it's like a fake-looking tornado
Yep.
funnel cloud.
So basically, it's a cloud in front of the storm. So it's between you and the actual storm. So it looks like it could be a wall cloud. It looks like it could be a tornado or a funnel cloud. But really, it's just an innocent little puff of cloud between you and the storm. And it looks like it could be something really, really bad just because there's no light reflecting behind it because the main storm is blocking the light. So it looks darker. So really, it's nothing. So when you look at it, really give it a second glance and say, is that really attached? And if it just looks like it's starting to float away, then odds are it's not attached to the storm. It's not a threat. Oops. All right. So just how much severe weather do we receive? So in the United States, heat is the primary killer of anything, followed by lightning, followed by the flooding and tornadoes. Now, heat, definitely want to keep track of your neighbors, your elderly neighbors, family, because heat, as you see there, #1 killer. So this is, next couple of slides just shows you where in the United States a lot of severe weather happens. Thunderstorm climatology, so this shows average days per 10,000 square miles where there's severe storms, followed by strong winds, a little bit outdated data. I think the National Weather Service needs to update some slides. Tornado Alley. We all have heard about Tornado Alley. And then you got the tornado climatology. So this shows the number of average tornadoes per 10,000 square miles by state. which is all in this area right around here. And again. So the primary times of a tornado is going to occur in the springtime, but that doesn't make it safe in middle of January, like right now. A couple of years ago, I witnessed a tornado in the middle of January. It was the first tornado in the United States of the year, and I got to witness it. It was an F1. Wasn't that severe, wasn't that strong, but it was still a tornado. It caused pretty good damage. And it was the middle of January, and 2 days after that, we had a blizzard. So just because it's the winter doesn't mean you're not going to get a tornado. But main tornadoes are going to happen in the springtime. And time of day, what's the most likely time of the day to have a tornado? It's going to be in the late afternoon, early evening hours. So that way it's just enough time for the atmosphere to build up all that moisture, humidity throughout the day, through the morning, the early afternoon, and then late evening, it just lets loose and just hears everything all at once. So generally between 4 and 5 p.m. is going to be the sweet spot of getting that severe weather. So enough of the mumbo jumbo. We want to figure out how storms are made, right? All right, let's get out of that. Next topic here. All right, how storms are made. So we're going to start from left to right here. So you have your cumulus stage. So you have your updraft. Everything is flowing into the storm, not much coming out of it just yet. Then when it becomes its mature stage, that's when it's at the strongest point. So you have your updraft followed by your downflow of moisture. So your updraft is pulling up. It's pulling everything into the storm cell, which is keeping the precipitation from falling out of the front of the storm. Because there's so much of an updraft, it's keeping that rain pushed back where it falls. And then dissipating stage, there's not so much of an updraft. It can't keep that updraft, that upflow going. So then it just starts letting loose, and that's when it starts dying out. Common thunderstorm types. You have your multicells, your squall lines, classic supercells, mini supercells, high precipitation, and low precipitation cells. So multicells are just your ordinary thunderstorms. Typical spring, summer storms. Squall lines, that's a long line, a long band of storms, which you would see on some Doppler radar images we're going to show in a minute. And that's where you're going to find some moderate threats of like microbursts. That could be where Nikki was saying she's seen she had that strong wind burst out of nowhere earlier. So that typically comes out of a squall line. Then next is your classic supercell. So that's the rotation in an updraft, which is a strong updraft enough to cause rotation, and that's what causes you to get those wall clouds and funnel clouds and then spawn a tornado. Then you have your mini supercells, which is a smaller version of such storm, and it doesn't have quite as much energy to produce a tornado in most cases. High precipitation supercell is with the rotating updraft. And oftentimes, like when you have the high precipitation supercell, that's when you can get rain wrapped. So what rain wrapped is when you have a tornado, but it's wrapped in the rain. So a lot of times when you're spotting, if you're not positioned just right, you might not even know that tornado exists. So that's another reason you got to be really careful out there when you're out there in the storms. And then the other one is the low precipitation supercells. So that's when you have the rotating updraft with light precipitation. Generally, it's a low tornado threat, but that doesn't mean that you're not going to get a tornado. We just covered that. So supercell features is you have the mesocyclone. The mesocyclone is in the upper part of the storm. That originates about 2 to 6 miles in diameter and is in the upper layers of the atmosphere. And its defining characteristics, it is the defining characteristics, I can speak, of the supercell. Generally below that, you may end up seeing the wall cloud. So the wall cloud is the abrupt, pronounced lowering of a cloud. As you can see in this image here, you see right below it, that lowering of the cloud here is your wall cloud. And once you get that wall cloud, that's where you can get the rotation. Once you get the rotation, then it can form the funnel clouds, followed by your tornado. So an example of the different types of cells, of the storm cells. Start out here, you got your updrafts for cell 4, cell 3, gets a little more precipitation, then Once it hits that upper stages, you're going to get your downdrafts and a lot of your rain. Multi-cells, again, you got your updrafts pushing in, causing the rain on the downdraft, and here we go. Squall lines. So this is a squall line. So the map indicates your counties and states. Like I said, it's a very, very long band of storms. Generally, the severe parts of the cells, or the severe parts of the storms, are going to be in the front parts of the squall line, and really you don't really have to worry about midway and behind it. So you're going to get a lot of your heavy precipitation hitting you, your wind, tornadoes. That can all happen right in the front line of the band. Here's an image of looking at a squall line in person from a distance. Got your nice anvil shape cloud. Here's another image of the anvil. So you have your updraft, rotation in that updraft, which causes that wall cloud and possibly even a funnel and some rotation down there and a tornado. Then your heavy downdraft, causing heavy rain and hail. Another image of your updraft with the mesocyclone. All that could be rotating, pulling the moisture in this direction, and then causing the downdraft, which is where you're going to have your downpour and all your hail. Another image of hook echoes. So you see here on both these images where you're going to see where that tornado is going to form, which is right here, where you have everything meeting. It's a better image. So you have your updrafts and downdrafts and everything going haywire right in the center. Rear flank downdraft. So behind the cell, you can see the darkness here. That's not all just dark cloud. It's rain, hail. Here's a good image of a wall cloud here forming. There's probably a lot of rotation with that too. I'd be reporting that one for sure. Sources of straight line winds, same deal. Your squall line is here. Here's the front of your squall line. You're going to get a lot of straight line winds coming out of the cell right in here. Right in here. So how to tell when you have a very strong updraft. So if you notice here in this image, you have the top of what we call the anvil. So if you look at it like, Roadrunner and whatnot, you have the anvil that the coyote drops on the Roadrunner. So normally that's just a flat top. But when you have this little overshoot right here, see how that's peaking up? So that's caused by the updraft. So the updraft from that wind coming up into the storm is so strong that it's pushing the top of the cloud upward, causing that bubble. So that tells you that there's going to be a huge updraft, meaning there's going to be a whole lot of precipitation that follows that. Here's another good image of showing you what the cloud looks like with that strong updraft. And because that updraft is so strong and intense, probably got a lot of rotation in there, well, that spawns a tornado. Another good image of it. Artist rendered. Good artist, right? I think we should do some of these models here in Samsar. What do you guys think? Give them the National Weather Service. So here's supercell, high precipitation supercell, just a few images of some different ones, just so you can keep a little mental note in your head of not all storms are the same. Just flip through a few of these. That one looks pretty cool. Oh, check that one out. Little second delay there. This one looks real cool. Okay, low precipitation supercell. So you have a light updraft. Could it spawn wall cloud? Could it spawn tornado? Yes, it could. But again, it's not as likely. And you're going to get light rain and some hail. Again, generally speaking, they're not going to cause you much trouble. So when you're spotting a storm, where do you want to position yourself? Generally, you want to position yourself south-southeast of the storm. That way you're going to get the best viewing distance, or the best clearest viewpoint of the storm. Again, so this is what it looks like spotting from that location. North is directly in front. And that way, if you're south-southeast as the storm is moving, if you're stationary, by the time the storm passes you, you'll be south-southwest. And that way you'll get a good view from the entire path of the storm as it goes in front of you. Generally try to keep yourself as a spotter a couple of miles away from the storm. Don't put yourself in danger. Don't go in the storm. Viewing angle from behind the storm, once it passes you, yeah, you can go behind it. Just don't position yourself in front of it, because if this is moving in front of you and there's a tornado in there, you probably aren't going to see it if it's wrapped up in all that rain and everything else going on and hail, and you don't want to put yourself in danger if it's coming at you. So again, you want to position yourself south-southeast of the storm if possible, especially if it's moving, due east. If it's moving south-southeast, go more south. So in this image here, we'll flip that on, and you see you do not want to be in that red. Obviously, the storm is moving east-northeast. So your shelf cloud, I'll cover a little bit more shelf cloud in a minute. Your inflow, updraft. And so we're going to take a quick look at a time lapse of a rotating supercell. So check this out. Okay. So that's time lapse. Let's look at it at a real speed. So this is what you'd really be seeing on the ground in real speed. Same storm, same spot, same video. I think that one's pretty easy to see the rotation happening.
Yeah.
Yeah, I wouldn't want to go any closer than that. That's plenty close. Yeah, and definitely steep drop off. Be aware of your surroundings too. Don't fall off a cliff. Fall off a cliff and then the tornado comes and sucks you up. You got quite a few issues. All right, so the next one, updraft characteristics. So again, like I said, you're going to get that cumulus tower, and that's caused by the heavy, high updraft upflow from the wind, so that pushes all of the cloud formation up higher into the atmosphere. So from a distance, you'll be able to easily tell that there's an extreme or a high upflow based on the height of that cell. Downdraft. Again, same deal. If you got heavy updraft, you're probably going to have a heavy downdraft, and that's where you're going to see the darkening in the formation, where you see the rain and the moisture and whatnot. Here's a good image that shows a heavy updraft, an upflow. You can see that moving up, peaking above the top of the anvil, and then causing in a torrential downpour behind it. And then here's just a big updraft. You can see punching through that anvil here, and it just goes way up there. And another image. All right, so upper level storm strengths. These are some pretty cool images. You can really see that anvil shape that I'm talking about. I mean, I just keep picturing all those like Roadrunner episodes and stuff that I used to watch with my grandpa all the time. And then not so strong, dominant anvil clouds right there. We've seen this before. So then you got wall clouds, wall cloud characteristics. So that's a subsurface base inflow under the updraft. So basically you're just getting that lowering right here, which is attached to the cloud base. Make sure it's attached, because otherwise a lot of times people confuse the wall cloud for a scud cloud. A scud cloud is not attached. That poses no threat at all. If it's attached to the storm base and it's a wall cloud, that poses a threat. Look for persistence, look for rotation. It may or may not rotate. even if it's not rotating, it still could be a wall cloud, could still pose a threat in the future, very near future. Once that starts rotating, then that forms the chain of producing a tornado. And look for vertical cloud motion. And often it slopes or points toward the precipitation in downdraft. So next slide, you can see it going on here. There's a nice wall cloud. And then differences, shear, just really quick descriptions. Shear is your winds going up, down, in and out, rotation, of course, is rotating, spinning. Okay, we got that. Couple pictures of the wall cloud, just so you can see again, not all wall clouds are treated equal. They're not all created equal. They always look different. Some are going to have rotation, some don't have rotation. If they have rotation, that's going to be taken a lot more seriously because the next step is producing a funnel and tornado. Another wall cloud. This one looks like, it's pretty cool looking. Flip through some of these. This one, a lot of people might look at that and say, oh, it looks like there's a tornado, but sort of hard to tell quite a ways away, but that's just a wall cloud, not a tornado. Again, this might look like a giant tornado, but it's just a wall cloud. But it is the steps to form a tornado. It's another cool looking wall cloud there. Again. And after the wall cloud, next step comes, like here's your wall cloud up here, and that forms your funnel cloud. So once you get that funnel cloud started and you start getting that rotation, you have a tornado being born. This is the starts of a tornado. So funnel cloud is rotating funnel-shaped cloud that extends downward from the base, but it is not touching the ground. So if it is not touching the ground, it is not a tornado. That is just a funnel cloud. So the signs of tornado threat may be increasing. Your inflow of winds are increasing. So remember, you were looking for those higher clouds that indicate that strong updraft. So keep an eye out for that. Watch the updraft base becoming more and more circular shaped. Same thing with the wall cloud. Watch the wall cloud for rotation. So here's a cool time lapse we'll take a look at.
Underside of the wall cloud here with a very prominent funnel cloud. And this is what I say whenever I keep saying it's a prominent feature. This is not just a true funnel cloud is not just some ragged piece of cloud, but rather it's going to be something very pronounced, strongly rotating, and right underneath the wall cloud. So we'll let this video keep going here. You see very quickly the funnel starts to lower towards the ground, and then boom.
There you have your touchdown.
We have a tornado. Very short-lived, but you can see how quickly these can develop when you have this strong of a rotating wall cloud, strongly rotating funnel cloud.
Oops. All right. So you've seen that tornado. It was very short-lived, only a couple of seconds, but it touched the ground. Therefore, that is now a tornado. It is no longer a funnel. So tornado warnings get issued for sure. Definitely report. Even the funnel clouds report it. So we all know, or I think most of us know, what a tornado is. So a tornado is a violently rotating column of air that is extending from the base of the cloud to the ground level. And you will notice there is a debris cloud right below it, and that indicates that there is touchdown on the ground. That's your debris cloud from whatever's around there, dust, dirt, trees, cows and twister, you name it, that's where you're going to find it. I know Nikki likes seeing those cows fly across the farm, right?
It's the same cow.
Slam a tree or something.
So
Clearly,
here's a funnel cloud. Yeah. Yeah, that's for sure. Every time I see a tornado in person, I always turn to whoever I'm with and I'm like, you, keep your eye out for flying cows. They just kind of look at me like, really, you're thinking of that at a time like this? Yes, I am, because I'm that crazy. So, but yeah, will a cow really be flying? No, you're not going to have a cow flying in front of you. If you're close enough that tornado was able to pick up a damn cow, you're not looking at the cow flying in front of you. All right. Yeah, this is a funnel cloud. Is this tornado or funnel cloud? Really, that one. Let's just catch up. Really, that one's kind of hard for me to tell because I don't see a debris cloud. So that one's kind of hard for me to tell without seeing any motion. Maybe there's a slight debris cloud in some of these images, but without the image, like the video, some of them are hard to tell. Like this. Is this a funnel cloud or a tornado? How would you report that?
Funnel.
Yeah, I don't see a debris cloud, so I would go ahead and report that as a funnel cloud. What about this one?
Whoa.
Funnel.
There it is. Sorry. Yeah, I would report that as a funnel cloud as well. Tornado? Let's see.
Nope.
Yeah, I don't think so. How about this one?
Funnel.
Yeah. Probably I would do funnel as well, because I don't see any signs of a debris cloud. So again, this one tells you the answer here. No, it's a wall cloud. This isn't even a funnel cloud. Funnel cloud or tornado?
Funnel.
Yeah. Funnel cloud or tornado?
Tornado.
How about this one? Are you guys going to say, is there a funnel there or is that a tornado?
That's a tornado.
Dirt in the bottom's tornado.
Yep. There's the debris cloud right there. Arrow points to it.
Yep.
So even though you're in a town, it doesn't mean you're safe. All right. Let's watch a time lapse. Is the time lapse going to work for us? Let's skip ahead and go back. Let's see. There we go. All right. You'll see it in a sec. Look to the right of the road. See it really quick. Just to the right of the road down there.
Holy shit.
Yeah.
Yeah.
Pretty cool, huh? Cool as long as nobody's in the path.
Right.
Land spout. Okay, so this is something that can form out of a cumulus cloud not associated with larger rotation, such as the mesocyclone, but it can connect and form a horizontal shear to the ground. So that's just an extreme up-down draft shear and can cause destructive winds. That could also be what you experienced there, Nikki. So another one is a land spout. It causes the same tornadic damage. Generally, it's going to be more in your open plains areas, people that live in deserts and farms and whatnot, but that'll happen pretty much anywhere. We've seen this image 1,000 times. I don't know why they put the same image in there so many times. I guess they really want you to pay attention to that. Shelf clouds are pretty cool too. Okay, so a shelf cloud marks the leading edge of a gust front, usually produced by rain or cool air, and usually in the front of like a low-level shear slopes away from the precipitation, and it's generally in front of a squall line. So generally in that long line, that band that we've seen on the radar, you're going to see this in front of that. And sometimes it can get really cool when it really gets going, and it'll rotate, but not rotate in the way you would think, but more of a horizontal rotate where it's like rolling, like you get what's called a roll cloud, and it'll roll across the sky. Does it pose a threat? You might get some wind, but when it starts rolling like that, it's just a pretty cool thing to look at. Expect some wind, hail, severe thunderstorm criteria. Here's a good example of the shelf cloud. You get a microburst out of this one too. You got the heavy updrafts giving you the heavy downdrafts, causing what could be tornadic wind speeds coming out of that. Looks like, is that a lightning strike? That looks like lightning right there. Look to the right of that, right underneath that right arrow. That looks like a lightning strike. That's pretty cool. So I just noticed that as I'm doing this right now. I'm like, oh, lightning, cool. But lightning is dangerous. Keep that in mind for later. Another shot of some shelf clouds here. Shelf clouds, like I said, they indicate the front of a squall line. Squall lines can also produce tornadoes as well. So do keep an eye out for some possible wall clouds that get associated with any of that. Here's a really nice, smooth, lowering base. This looks like this is probably a shelf cloud that's got some rolling rotation in with it. That's pretty cool. Just some more. Look at this. Prominent. Look at this. Look at how smooth and clear that is. That's just perfect. Can you guys tell I like to go out and chase tornadoes and storms?
Yep.
All right, so check out this time lapse.
Oh. Jeez. There's a ship in there.
Yeah, that's pretty cool. Too bad you can't actually see things moving in that speed in person, right? I mean, when you're out there looking up at the sky, it'd be interesting. All right, so wall cloud, shelf cloud summary. Associated with the updraft, wall clouds, yes. Shelf clouds, not so much. Associated with the downdraft, shelf clouds, yes, because you got a lot of precipitation moving downward behind it. Often slopes towards the rain. The wall clouds slope toward the rain. The shelf cloud slopes away from the rain. Sometimes associated with tornadoes. Shelf clouds, yes. Wall clouds, no. Wall clouds are with tornadoes. And favorited areas for rotation, wall clouds. Wall clouds are where you're going to get a lot of your rotation because that's happening in generally the updraft where you got a lot of that spinning going on. And when that spinning is going on, then it forms the wall cloud, which forms the funnel cloud, which forms rotating funnel cloud, which forms a tornado on the ground. And once again, that image comes back to haunt us, damn it. All right, we mentioned gustnadoes. So what are the gustnadoes? So a gustnado is short-lived, low-level base velocity, usually along a gust front, generally not associated with the mesocyclone, wall cloud, or the updraft whatsoever. So you're going to look for rotation, not just blowing dust, and it can cause damage to structures and can be hazardous to people in open areas. It can be correctly identified and reported as a gustnado, not a tornado. I mean, sometimes you might even get this just cyclone miniaturized gustnado that just forms in a field or an empty parking lot. So sometimes, like I've experienced it in person, where I'm just standing in a parking lot and all of a sudden there's this spiral of leaves and twigs and branches and dust spinning around me, and it doesn't cause any damage. It's not really dangerous. When they're very small, but that's in a parking lot in like a rural area. Once you get that and put that in the middle of a desert or a farm, that can build up. So then it can be potentially a little bit dangerous. Here's like I'm saying, in a big field, it can grow and become a little dangerous. Might knock you off your feet, blow some big branches into you, and hurt you a little bit. We've already covered some of this other stuff here. Can it be seen by radar? No. So that's why we need spotters on the ground. Does the gustnado form from the cloud base to the ground? No. Forms on the ground. So keep that in mind. If you see that spiral on the ground, but it's not connected to the top of the structure of the storm, then it's probably a gustnado. So just touching one more time on the scud clouds. We mentioned them a few times before. Scud clouds, this is a scud. It's not a funnel cloud. It looks like it's a funnel cloud, but that's not attached to the storm. Therefore, it is a scud. It's an imposter. It's fake. It's just a little puff of cloud smoke between you and the actual storm. Generally, the storm's going to be moving a little bit faster than the scud clouds, or it could be vice versa. So if you see that little scud moving off here and the storm is here, or you see the storm moving because it's at a higher rate of speed than the scuds, then that's generally a good indication, hey, this is an imposter, it's a scud, it's not really a part of the storm, it's not attached. So other weather phenomenon, got hail shafts. Hail shafts are pretty cool. You can see the hail from a distance. See how thick this is and bright because it's reflecting a lot of the sunlight. Good one here on the next image, you can see it bowing out. And that bowing out really is a good indicator that you got the hail in there. So you got the cloud all on the upper part, And then the solid white here is your hail shaft, and it's bowing out. And that's pretty cool. Here you can see the hail just streaking its way through, which looks really cool. Don't want to be caught in it, though. Don't try not to get caught in that. That causes a lot of damage. Outflow dust, you get dust. A lot of storms will pick up a lot of dust from the ground, especially if it's like really dry conditions and whatnot. You got your rain foot. You got your mammatus clouds. Now, mammatus clouds, I've actually witnessed these. These are kind of rare.
Yeah, I've seen them too.
And yeah, it's pretty rare, but when you see them, they look really, really cool. It's like, imagine cotton balls hanging out of the sky.
So
and
trippy.
Holy crap, yeah, it's like, what the heck is going on? A lot of people freak out, and they'll call the forecast office and be like, oh my God, what's going on? Is this the apocalypse happening? But it's just perfect conditions that form these really cool looking puff cloud balls floating in the sky. No hazard, no threat whatsoever. Just really, really cool to look at. So if you see them, you're lucky. It's really cool. So we'll do some lookalikes, funnel clouds, tornadoes. I mean, it's kind of hard to tell. I'd report some of these as wall clouds, not really funnel unless I see some rotation in them. As I would do as a wall cloud. Same deal here. I mean, some people might say, hey, that looks like a funnel, but I don't know. Again, this one's kind of questionable. I'd have to see this one in person, but it looks like it might be just a low-hanging, rotating, possibly wall cloud there. It's kind of hard with some of these images without seeing them in person. So just look at the rotation. You generally see a cloud behind. Look at the clouds that are behind versus the clouds that are closer to you. See if you see clouds start going in the distance one direction and then the ones closer to you go in the other direction. You got rotation. So it's a good way to tell. If all the clouds are all going the same way, generally it's not going to be rotation. So another thing to think about too, outside of just storms, I want to touch a little bit on some of these other things too, is earthquakes, right? A lot of us, especially in Sansar, we're a global community. We're not just locked into the United States. So fault lines happen everywhere, and fault lines are generally where you're going to have an earthquake. Now, does that mean the earthquake is going to always happen on a fault line? No, it's not going to always happen on a fault line. But generally speaking, if you live on or near a fault line, you have a much higher risk of living in a earthquake. So definitely remember, once the pressure, you got two tectonic plates pushing against each other, causing pressure, builds up more and more and more over the years until it eventually shifts, and you get that earthquake. Once it shifts, just causes a lot of destruction and damage. And in certain parts of the world, especially if you live near an ocean, you can end up with tsunamis and whatnot. So let's take a quick look at a recent outbreak that occurred, or a recent earthquake.
And aftershocks rocking the island, killing a man and knocking out electricity for millions. Victor Okendo is in the hard-hit city of Guanica, where they're feeling aftershocks right now, Victor.
That's right. Good morning, Michael. We felt tremors throughout the night and this morning. This is one of several homes in this neighborhood that was destroyed. Thankfully, no one was home at the time. The USGS warning, we can expect more seismic activity in the days to come.
This morning, a state of emergency in Puerto Rico, the island reeling after the latest quake. Aftershocks forcing television news anchors.
This was just like a week or two ago. It's about a week and a half.
A 6.4 magnitude tremor leveling businesses and homes, damaging schools.
They had aftershocks for days and days.
The powerful earthquake killing 73-year-old Nelson Martinez. His nephew finding him buried in the rubble. A wall had collapsed on his bed.
We tried to, at least the part that it was here and here.
You tried to remove it?
Yeah.
But it was too heavy?
It's too heavy, but I remove it.
Emergency crews now dealing with the aftermath, like this massive rock slide on a highway completely blocking cars from passing through. This hospital evacuated, nurses tending to patients lying on beds outside. At one point, the entire island losing power. The San Juan airport running on backup generators. Authorities in Puerto Rico now saying most of the island will have power by the end of the week. Hundreds now in shelters, many in tents, afraid to go back inside.
More than 1 million customers are still without power this morning. The biggest power plant on the island sustained severe damage so bad they might have to call it a total loss and build a new one. Guys?
My goodness. Okay, Victor, thank you.
All right, so yeah, earthquakes, anytime, anywhere, and it can pose some serious threats and damages. So next, I actually have a video. This may be a little bit intense for some people. Just a heads up, you're going to hear a lot of real-time screaming and whatnot. This is the 2011 tsunami that went through Japan after they had that big earthquake.
Oh yeah, I remember that one.
Sorry, I paused it for a second by accident. Tsunamis are definitely something you want to think about if you live near an ocean.
Yep. About like
California,
50 minutes. Yep. We get a lot of
Washington,
earthquakes.
Oregon, Mexico,
Southern California
on the
usually
coast.
gets more earthquakes. Like if it hit the
And
fault
they move
line,
quick.
like in California, there's a fault line here. You hit that, and one finger is completely gone.
Interesting bit of music in the middle there.
Right. Trying to drown out the cries.
Yeah. I mean, imagine, having your home there.
I couldn't. I'd be running down in there trying to pull people out and get killed in the process.
And people that don't listen to the warnings and they think it's not going to happen to them. And they got to make that last effort and run as fast as they can to try to save their life. Look at, there's people down there. But yeah, take warning serious. Take all warning seriously. Like, don't risk it. Don't risk your life.
Way too many people died during that.
Okay, so hopefully the people that we've seen on camera survived, but definitely safety is your top priority. It's your number one concern is your safety. So if you decide to go out and spot the storm, go as a team, go as a group, 2 or more people preferably. It's always best to have the extra pair of eyes as needed to watch the skies above and behind and around you. If you're driving, especially, you want to focus on the road. There's many road hazards that can be around you. You don't want to be looking at the sky and end up hitting a tree, or you don't want to be looking at the road and then end up getting sucked up by a tornado. So it's always best to go with 2 or more people when you're spotting out on the ground. Don't speed. Of course, rain, speed, high speeds, hydroplaning, that just doesn't work. You end up crashing, and if you crash, get stranded, and a tornado comes because you're out there with the tornadoes, you're in some serious trouble. Avoid dirt roads. We've seen that one video where they're on that dirt road. You don't really want to be on a dirt road because if you end up bottoming out, or you end up getting stuck, or that turn it rains and you get mud and you're going to get stuck, you can't escape if you need to. Mobile homes, mobile home parks, definitely want to avoid those as well. What else is there? When you're mobile, don't take shelter under an overpass, because that's going to form like a vacuum. So we'll cover that in the myths section, which is coming up here. We're about done. We just have a few more slides, guys, and then there's some cool videos to watch. When spotting the tornadoes, try to keep at least, like I said, I try to keep at least 2 miles between me and the storm. They're saying here 1 to 2 mile safety buffer zone. I try to keep myself about 2 mile distance, because I don't need to be caught in the middle of the tornado. It's not worth it. As long as you're able to see the storm, report the storm, that gets the notice over to your community, that gets the warnings going, that tells everybody to take cover. That's all that's needed. You don't need to go inside of the storm. What are you going to do? Stand there jump around in the tornado? It's not going to end well. If tornado approaches, when possible, move away at a right angle to the tornado, because generally tornado is moving to the east. If this is not possible, abandon your vehicle. Look for a sturdy structure such as a house. I can talk. Yeah. If no shelter is available, lie flat in a ditch and away from your vehicle. You don't want your vehicle to become a projectile that'll come and kill you. So try to get away from your vehicle and get in the ditch. And if you're indoors, of course, we all know this one. Safest place is in a basement. If there's no basement available, get to a small interior room on the lowest level away from doors and windows. Again, this is just recapping what we just said. And touching on one other thing that hasn't been mentioned yet is the National Weather Service has the motto, turn around, don't drown. So when you encounter a flooded road or a blocked road, don't bypass the barricades. Don't just say, oh, it looks like I can make it. Turn around, don't go through the flooded roads. 3 to 6 inches of water is enough to wash away a vehicle. And it doesn't matter if you're 4-wheel drive or not. I mean, you could start floating, and especially if you're near a river or something, generally you're going to have heavy currents, which can just carry your vehicle right off into the river, and away you go. So turn around, don't drown when you're encountering flooded roads. Don't bypass road barriers. Don't think just because I'm a spotter I can go anywhere. Follow the rules of the road. And avoid core punching. Don't try to drive directly through a supercell. If you're spotting the storm, stay on the outskirts, stay to the south, like we said, in the safe areas. Don't try to drive directly through the storm because, well, look at that picture. Now somebody needs a new window. And quite a bit of body work. And let's touch on some lightning safety. This is where it gets a little interesting. I like lightning.
I've
Lightning.
been hit twice, so be careful what you say.
Damn. Yeah, lightning can be very cool to watch, but it's also one of nature's deadliest killers. So the safest place to be is indoors during lightning storms. Stay away from windows and electrical appliances. When you're mobile and out and about, the safest place is to be inside of your vehicle. When you're in your vehicle, the vehicle's grounded. The lightning will go around you, not through you. Stay inside the car. Don't get out of the car. Don't go into a field. Don't go under a tree. Avoid the tallest objects, like it says in the next thing there. I think I'm skipping one. But yeah, avoid the tallest objects. Stay away from other things such as trees, power lines, power poles, tall buildings. Get inside the building. Don't stand next to the building. And if you're mobile spotting, don't park along fences, fence lines, power lines. Be aware of power lines. Don't park under the power lines. If lightning strikes that pole or a tree falls down and hits that pole falls over, that line can fall on your car and it's a live power line and you're trapped in your vehicle. Stay away from power lines. And always remember, if you're close enough to hear thunder, you are in danger of being struck by lightning. If you can hear the thunder, you can be struck by lightning. Again, this is just following up, again, on the lightning safety. So here's a little clip from the NWS.
If you can hear thunder, you can be struck by lightning. You should immediately move into a safe shelter and stay there for at least 30 minutes after the thunder stops. Remember, when thunder roars, go indoors.
Ow.
You are startled by a particularly loud clap of thunder. Strikes seem to be more frequent now, based on the increasing rumbles. The sky has been growing louder, and now you pinpoint the storm which is doing most of the talking. The clouds have grown very tall over you, spreading out across the sky. According to your spotter training, you need to get inside to keep safe from the lightning. You throw all your tools in the wheelbarrow with a clink of metal and head for the garage. You hear the first raindrops hitting your patio and feel their cool, wet impacts on your bare skin. The smell of fresh rain rises from the ground. You have a good view of the upper tier of the storm from your garage. The slate-colored skies are getting closer. The squeak of the garage door announces your presence in the house. The rest of the family is in the living room watching TV. The familiar tone alert for NWS warnings echoes in your ears. Your children complain about the interruption, but you are thankful for the warning. Rushing to the living room, you ignore the groaning and ask your family to quiet down so you can hear the warning.
All right, so basically, always make sure that you're able to get your warnings and stay away from lightning. That's what we get out of that, right? I hope so.
It was a little short.
Yeah, it was a little short. So, touching on that subject as well, again, lightning is one of the most beautiful displays in nature, but it's also one of the most deadly. So, a thunderbolt happens when temperatures are, or a thunderbolt is, or a thunderbolt, lightning bolt, right? Oh, man. Yeah, I'm ready for bed now. So a lightning bolt has temperatures that are hotter than the surface of the sun.
Yep.
And our shock beams beaming out in all directions. So it's, you get struck by that and it's very deadly. So let's check this out. You might want to turn your audio down a little bit. This one is kind of loud. If it'll play, there we go. All right, we're playing.
No, I'm not.
Oh, I wouldn't be in a big open park like that.
Holy shit!
Don't be under the power lines.
He goes indoors.
Yeah, I think it's time to get inside.
Oh my god!
She's just like, oh yeah, I'm gonna go inside. Yeah, power lines.
Nice.
Boom.
Damn.
Got that on video!
I think I've seen this one on Ridiculousness. Cabin looking one.
Whoa!
That's cool. Those people are pretty crazy standing right there with all the lightning.
Wow.
That junk's right over my head.
Whoa.
Oh my God! Are you kidding me?
See, that's when your adrenaline starts pumping.
Sorry, you lost internet.
That's not good.
Welcome back.
I'm sorry, Mike. I was trying to put it at the screen to simulate the turn.
Ooh.
Thank you, Bob.
Wow.
Wow.
Very
God they weren't
bad
in the
place
water.
to be in the middle of a storm. You are the tallest object. Very wide range. Stay out of the lake. Listen to the forecasts before you go boating. Ooh.
Wow.
Dude.
Oh my God.
Zero, this reminds me, I have to tell you something about my cell phone capturing lightning video. I need to tell you about.
Yeah, I have to catch up after this. I'll set off the alarm. Yosemite.
Tää van här är det va?
It's like Japan.
Ё-моё, лупануло прям на... Прямо...
Oh, this one's cool.
On Monday, the rain came again.
Monday, the rain came again.
My God.
Whoa.
Sure that was lightning and not like
I know, I never seen one leave a smoke trail like that.
Yeah. Probably took out a rooftop unit or something.
Either that or that atmosphere is totally polluted. Same one, they just darkened it.
Yeah. So I think we're just kind of getting backtracked here a little bit. So yeah. So yeah, definitely when it comes to lightning, definitely look at your surroundings, look at where you are, keep yourself safe, stay inside the vehicle if you're outside, and if you're able to get indoors, stay indoors. Don't go outside in lightning. Definitely don't go on a boat in the water, and stay away from trees and especially power lines. You've seen some of those power lines shooting sparks everywhere, and if one of those poles snaps, live lines come right on your head, and it just, it doesn't end well. Stay away from power lines, be aware of your surroundings, stay indoors, and if you're out in your vehicle, stay in your vehicle. Don't risk it. Another thing, flood safety, like I've been saying, to turn around, don't drown, stay out of flooded roads, don't underestimate the power of fast-moving water. If water levels are up to the edge of the bridge, even though the water may not be covering the top of the bridge, I wouldn't really want to pass it just in case it's making that bridge structurally unsafe. You seen that one image earlier where the center of that bridge was collapsed. Be aware of things. If a large tree trunk comes floating down that river and hits that bridge, takes it out when you're on it, you're now in the water, and now there has to be a search and rescue, and hopefully you'll live through it, and you lose a vehicle. It's not worth it. Turn around, don't drown. Also, you never know. Look at these images. I mean, without that vehicle in there, you'd never know that there's no road right there. The road just washed away, apparently, a sinkhole, and it's not worth it. So turn around, don't drown, don't try to drive through it. If you get stuck, you're going off into the river.
The NWS advocates the slogan, "Turn around, don't drown. Don't ever try."
Sorry, guys.
The NWS advocates the slogan, "Turn around, don't drown. Don't ever try to cross running water, either in your vehicle or by foot." Most individuals are surprised to find out how powerful moving water can be, even if it is shallow. Just 6 inches of fast-moving water is enough to knock you off your feet, and 2 feet of water can float most vehicles, including SUVs like yours. If the water is moving fast, it can sweep your SUV off the overpass.
How do they know I
and
have an
into the river.
SUV?
To be safe, turn around and look for an alternate route. For a split second, you think about racing across the water. Instead, you slowly back out of traffic and turn around and move to the side of the road. Looking back on the river in your rearview mirror, you notice the other cars hesitating before crossing the rising water. You reach for your phone, thinking about how dangerous this situation could become.
Okay, for some reason
They
the
really
rest
cut those short, don't they?
of the video seems like it didn't play, but yeah, turn around, don't drown, and be aware of your surroundings once again. When nighttime spotting. Mobile spotting at night is especially dangerous. You can't really see where the tornadoes are. I wish they had a better video. I wish there was a video of it. I should have grabbed one off the internet to add in. It's one of my extras. So when you're storm spotting at night, you generally cannot see the tornado. So really you have to only tell in flashes of the lightning when there is a tornado. And generally you can't see the actual rotation. So you only get like a split second. So it's best to have 2 people spotting so you can focus on the road. You got one set of eyes on the storm. Also note the wind direction, as wind direction can change. You don't want to be caught in the path of the tornado or the severe thunderstorm. Like I said, utilize lightning as a way to see. Every strike of lightning, you really want to get a quick glimpse at your surroundings and be aware of your cloud formations. Know the direction you're going in relationship to the direction that the storm is traveling, and don't confuse shelf clouds with wall clouds, and look for signs of rising or rotating clouds. So if you see a flash of lightning and you see a cloud going east when the storm is going east, and then another flash of lightning and then more western, and there's signs that there's rotation, try to keep an eye on that spot. And yeah, the other thing that you want to look forward to, I don't think you want to look forward to it, but you want to look for power flashes. So generally when you get a tornado at nighttime, you'll notice as the tornado is moving and taking out power lines, you'll notice the transformers start blowing. And when the transformer blows, you'll get these crazy cool looking glowing flashes coming from the ground. And that is usually transformers blowing up from the power lines, and that indicates that there is something going on the ground, and you can generally pinpoint that there's a tornado happening from that. Spotters. So spotters, you must know the difference between the shear and the rotation. So the shear is the upward draft, down draft, moving in and out of the storm, and then you got your rotation around the, that goes clockwise, counterclockwise. You know what rotation is. Come on, we're in Sansar. We're not that dumb. You got to know the difference between the shelf cloud and a wall cloud, which is what we covered here. Know that the funnel clouds usually do not form from the shelf cloud. Where do funnel clouds form? Anybody? Wall clouds, yeah. Know that the low-hanging clouds in the shape of the funnel, if they're not rotating, is not generally a funnel cloud because there's no rotation. So it's probably just a lowering of the wall cloud. And know the difference between blowing dust and a tornado. There's just dust on the ground and nothing happening in the sky. You got no wall clouds. That's just dust, probably dustnado. And do not over-exaggerate a report. If you go to call in a report and you're second-guessing yourself, take a minute, study what you're looking at, think again, think twice. Winds, don't forget those videos you've seen. Take a minute, look at the surroundings, what kind of damage is occurring prior to giving that estimate on that report. So pretty much just about done here. Let's just go over a few myths and let's do some myth busting. Can I say that? Is that copyright? I don't think so. I'm going with it anyway. All right, so myths. So the myth, I heard a loud noise outside. It sounded like a train. That has to be a tornado. Truth is, a very strong wind can make a roaring noise, sounds like a train, but that does not necessarily mean that you're experiencing a tornado. So when the wind twisted this piece of metal on my shed, the trees that were blowing down and they're all twisted, it has to be a tornado because everything's twisted up. Generally, you cannot look at any individual pieces of furniture or objects to determine if it was a tornado or straight line wind that caused it. Total damage pattern and how the debris is thrown around, that could be an indication of what's going on. Straight line winds can cause objects to twist around different objects, just like a tornado can. So you can't just say because all these objects are twisted, that means that it was a tornado. No. So next one, objects such as lakes, rivers, hills, mountains, Great Lakes, oceans, they protect me from tornadoes. Cities, skyscrapers, you name it, I've heard them all. That does not protect you from a tornado. Nothing more than folklore. These, as it says there, the features provide no protection and have no bearing on the development of tornado. Some thought that tornadoes would not touch down in a metropolitan city. Recent tornadoes touched down in Fort Worth, Salt Lake City, and Nashville. Another one, water spouts form. It's just a tornado that forms on the water. So if you have a tornado that forms on the ground, it moves on the water. Now it became a water spout. Now if that goes back on the ground, now that becomes a tornado. It's the same thing. It's just one's over land, one's over water.
Sharknado.
So, I think a Sharknado is also a myth because I don't think. Well, maybe an EF5. You know, like if you have an F5 category water spout over the water, maybe it could lift up the shark. I don't know that shark is going to survive. Well, maybe, but I mean, generally a shark is going to go way low underwater. I think Sharknado would be considered a myth. All right, mobile homes attract tornadoes. So mobile homes are not more likely to be hit by a tornado. They're just more likely to have sustained significant damage compared to a house or a large other building that gets struck by a tornado. Is it safe to seek shelter under an overpass? I'm going to read this one. Overpasses are not safe places to take shelter. They can funnel the wind flow, increase the strength of the wind. They do not provide protection against flying debris, and adding into that, think of it like a vacuum. So you have the tornado overhead, and it's blowing all the winds, and it's forming the suction, pulling even harder strength out of this overpass. Not to mention the debris flying in with you, and then you park your car under the stupid overpass. Now your car becomes a flying projectile. And then on top of that, if there's other motorists that are trying to get past the area and want to drive into the tornado, I guess, your car is blocking the road. So don't take shelter in an overpass. If a tornado is that close and you need to abandon your vehicle, get in a ditch. Get low below the ground. You want to avoid that debris that flies around. Get as low as possible in a ditch, in a culvert, and anything that can get you below the ground level, and cover your head. And stay away from your car, because your car can become the flying projectile to come and kill you. Another thing, we should open our windows if a tornado approaches. That's wasting time. Take cover. If you have a tornado warning and the tornado's approaching, take cover. Don't worry about your windows. People think, well, the pressure can change and blow up my window. If the pressure changes that much, that the tornado is overhead and the pressure's changing and it blows out your windows, the tornado's already overhead. You're going to have a lot more trouble than just windows blowing out. Don't worry about the windows. Get yourself in the basement or in an interior room on the lowest level of the building, of the structure. Stay away from doors and windows. Protect yourself. Don't worry about the windows. Tornado is coming and the pressure changes. That means the tornado's on top of you. You're not going to have windows anyway. You probably aren't going to even have a house. All right. So we got one little video. I'm not crazy about this one, but let's take a look at it anyway.
1965. I had been with the Spotter Network for
Good video. There it goes. Nope, maybe.
Tornadoes interested me ever since
Almost
I was
done.
a kid on a family farm. Sue and I lived in Dunlap, Indiana, up in Elkhart County. The day was kind of ordinary. Perhaps it
I know
was
exactly where that is.
a bit humid
Got an
for
aunt that lives out there.
We went to church. It was Palm Sunday. And then we had lunch with the Jacobsons. Later that evening, Sue was inside listening to the radio, and I went back out to work on a fence. I saw eerie, steely gray clouds heading toward us from the southwest. The clouds seemed to be falling out of the sky as I watched. Perhaps I was imagining it, but as it got closer, the sky was turning green. I never seen anything like that. It was almost out of another world. I haven't seen anything like it since.
Why'd the sky turn green?
I headed back toward the house. Sue met me on the porch.
We'll get to that in a minute.
Boy, she was in a fit. Henry, the man on the radio said a tornado is heading our way, and we should get inside. I would be caught dead outside with a storm like that heading toward me. Like I said, I'd never really seen anything like that before in my life. We spent the next hour in the dark, listening to the wind thrash our house and the rain pounding. We never really knew whether it was a tornado or not. Couldn't do anything about it anyway. We listened to boards cracking and glass shattering. And we just prayed for our lives in the basement. We had some damage, but the storm must have passed north of us. We were lucky. The houses up north were devastated. Later, we heard that a second tornado had moved through the area that night. Our friends lost everything, including their son.
Okay, so just because you have one tornado doesn't mean that you have completed the storm. There could always be sisters, is what they call them. You got more than one tornado. So always be aware, just because there's one, that doesn't mean that's it. There could be more. And then the other thing that I wanted to touch on too, and I heard somebody ask the question as well. You see my Naruto wallpaper there. So why did the sky turn green? So look at this green image here.
It's going green.
Yeah, so that's a pretty green sky right there. All right, so just because you have a green sky does not necessarily mean that you're going to have severe weather. Now, the reason why you get the green sky is because you have a heavy precipitation amount between you and the top of the atmosphere. So what's happening is it's causing like a filter to filter out the blue light rays. So that way you're getting more of the reds, the oranges, the yellows, all that combines with the moisture in the atmosphere, and it forms like this green hue. Now, it doesn't necessarily indicate that you're going to get severe weather, but that also doesn't mean that you're not going to get severe weather. All that is just there's a filter that's being placed between you and the rays of light that are passing through the atmosphere, causing a cool looking or scary looking effect depending on who you are and if you think it's cool or scary. Now, should you go take shelter as a spotter? You can look around, look at your surroundings, see if you see any indications. Do you see a wall cloud? Do you see any rotation? Do you see funnel clouds? Do you see, evaluate what you're looking at prior to making that assumption of, oh, this is severe, I'm going to go take shelter. Because like I said, it doesn't necessarily mean that you're going to be having a tornado. So that's been a thing that everybody has always thought of as, oh crap, I got a green sky, I got to go take shelter, there's a tornado here. That's not necessarily true. But that doesn't mean that that's not going to happen as well. So all that is just there's a filter being placed, kind of like looking through UV blocking sunglasses or something. So it's forming a filter in the atmosphere that filters the light differently. So other than that, that's about it. And I thank everybody for coming.
Thank you.
Thank you.
Thank you. And so I'm going to take a quick attendance one more time just to verify everybody is still here who signed up for the beginning. Get
Wait,
that
you had
logged.
to sign up in the beginning?
Yes, there was the form in the beginning. But as long as you were here for the first part of the attendance, then we can get you in there too. Which I think you were, weren't you?
Are you talking, is the form the internet page that you...
Yep.
Okay.
That was the registration. That was a sign up. Those two simple questions.
Yeah, I got stuck on a page where they want me to take a ad for a dog or something. Do I just close that out?
Yeah, just close that out. After you submit it, you're done. You don't have to worry about the rest. All right, so we're going to quickly take a look at this video. It's optional. And then after we watch this video, watch the tornado to the right. We're going to follow that tornado through on this video. And then after we watch this tornado, we're going to go check out a weather simulator here in Zanzibar. So definitely stick around and we'll take a quick field trip prior to the conclusion of the event tonight. This is pretty cool. These are storm chasers. Again, look at the road. So if you get a lot of rain there, I mean, even though it looks pretty smooth, still got to be careful being on a dirt road.
Wow.
Definitely a four-wheel drive.
They're kind of close, don't you think? I mean,
I
those things
think they're,
move
yeah, look at that. Look at how close they are,
They're
yeah.
fast.
That's
That's a little risque.
a little too close for me. They're chasers, not spotters, so, they get a little risky.
They're zooming in, too.
And that too, yeah.
Yeah, but those things move, like, really fast.
Look how close to those trees. Jeez.
They have people watching the radars inside the vehicles to make sure that rotation doesn't change direction.
You do got to keep in mind, though, too, that there is that slight delay factor in the radars.
Yeah, it does happen.
So definitely, if you're looking at that tornado, keep your eye on that tornado. Watch the direction that it's traveling. If it looks like it's not moving at all, and it starts getting bigger, it's moving towards you. Yep.
Yeah.
If it starts growing, and it's not moving left or right, it's coming right at you. Twister? Yeah. We got cows. You start seeing some cows fly past you. Dirt road.
Wow. The monster.
And always know your area. If you're out there spotting like that, always know your exit routes and have an alternate route. If that exit route gets blocked, you need an alternate way to escape if another tornado spawns.
What happens if you get sucked up by the tornado?
I didn't hear what you said. What was that?
What if the tornado sucks you up into its tornado?
If the tornado sucks you into the tornado, well, then you're history. It's been nice knowing you.
It'll rip you apart from many
So.
different directions.
Wow. Let's lose these wires. Let's go.
And the debris inside the tornado will shred you as well.
Yep. That's, like I said earlier, that's the killer, is that debris, especially. If you're out on the road, abandon your vehicle, get in a ditch, get in the low-lying area, get below ground level to avoid that debris.
Wouldn't it suck you out?
That's freaking crazy. It actually looks pretty. It's a mushroom.
Yeah, that supercell is very defined.
Richo, what was it that you said?
No, I said if you're like in a little foxhole door, it suck you right out of there, wouldn't it?
Could, but most likely you'll be able to survive it if you're in a low-lying ditch. You have much more chances of surviving that way than you do inside of your vehicle.
Oh, they're setting up a camera.
Yep, notice they are, I'm assuming north is directly ahead of them. Storm is moving, it appears to be east-northeast, so it seems like they are positioned in the proper position for storm spotting. Like I said, you want to be positioned south of the storm, preferably as it's moving towards you. You want to be south-southeast of the storm so that when it passes you, you'll end up being south-southwest of the storm as it moves past.
That looks scary.
Was that an F2? F3 maybe?
You're not going to be able to tell what it is until after.
Yeah, I mean, looking at it, yeah, without, you can tell by the damage after the fact, but just kind of looking at it, eyeballing. Yeah, I'd say maybe about F2, between F2, F3.
That's pretty scary. The camera angle is really good. How the water just kind of flies right off of it. That's really a nice camera, huh? Or is he just constantly wiping it?
No, it's the windshield wipers, but again, in the position they're in, they're on a dirt road, they're surrounded by power lines, that's pretty sketchy.
Look at this guy. Driving into the storm.
He just blasted.
Good lord.
Don't punch the core. Don't drive through the storm. You've seen the picture of that vehicle that punched the core?
Of that vehicle there?
Well, the picture was earlier.
Oh boy.
They're running. They're going for it. So now you're getting into the more of the downdraft of the storm. So here's where you can start getting some hail.
Ooh, what's that? Ooh my god, that's a weird looking one.
You see a debris cloud? It's a little rain wrapped.
Faintly.
A little hard to tell, but looks like tornado still.
Yeah.
So that's about it. So we'll go head over to the simulator here in a second.
Simulator.
Show a couple of these slides here, and also with social media and your phones, definitely. Anytime you're out there and you see something really cool, take a picture, take a video, send it to the National Weather Service. They're on everything. Instagram, Facebook, Twitter, Discord, they're on all of it. Send it to them any way you can. Just take some pictures, take some video, and submit it. It's useful for training. It's useful for any of it. So with that, thank you for watching. I will cut stream. and we'll get ready to go over to the simulator. Yes, you can, please. So let me just change the channel here.
There are 2 DNAs? Oh my gosh, Bella.
She emptied out this whole box.
Well, you know, those little aliens are very mischievous, so they can't help themselves.
Not cleaning it.
Are we supposed to be cleaning, packing them up in the box?
I have to make sure I have you guys all on the list because I had it as a closed world. We need to make it an everybody world.
Let's wreck this place, DNA.
Alright, it's an everybody world now.
You're getting hit by a tornado. You're getting hit by all the numbers in the tornado.
Alright, guys.
Oh, we're leaving?
Let's hit it. Here we go. So we're going to wait for everybody to get here. All right, I think we got just about everybody here that was in the event, so that's cool. All right, so everybody stand by.
Is my voice
So turn your audio up, and you're about to hear a official tornado warning issued by the National Weather Service.
Where do we go? I don't know where to go. Scary.
Go outside and make sure everybody's okay.
Right here.
We're supposed to run towards it, right?
Molly,
Stop it.
Hiding underneath. Get out of here. This is my spot.
Run towards the side.
Nope.
I will block you.
That can cover the tide under the server. Aw, come block the logic.
Over here. Chaos.
Indicated a severe thunderstorm capable of producing a tornado 4 miles northwest of Worthing, or 12 miles south of Sioux Falls.
Are you guys trying to get out? What are you doing?
We're stuck in here.
No doors.
We're on the drop chip. We're about to be dropping a battle royale for survival.
Minnesota. Potato.
Oh my gosh.
I like tornadoes. Zero.
I like tomatoes.
I like turtles.
Oh, what?
Uh-oh.
Let's go to it. So we're going to do what we're not supposed to do and run on foot to the tornado. And let's all gather in front of the houses. Let's all gather in front of these house structures here. And if we can stop about right here. Yeah, we can stop about right here. All right, so welcome to the simulator. So currently what we're looking at is an EF0 tornado. This is the damage that can occur after an EF0 tornado
But I'm
hits the
hiding.
area.
There's no shelter. Where do I go? That truck. That's the safest place.
Yep, this is an EF0. Doesn't, doesn't knock down houses and whatnot. Now it might, knock you off your feet. Might cause a little bit of damage, but we still got windows. We still got, our buildings intact. So that's pretty decent. Just a lot of wind.
Gonna hide.
So the next thing that we're going to experience is an EF1. So here's the EF1 damage. So if you notice, some shingles disappear off the roofs. Your glass in the windows all break out. Vehicle glass starts breaking. trees start bending, not necessarily snapped or uprooted yet. A barn or shed that's poorly constructed, such as the one on the right, that, you know, may lose a roof or here or something, just because it's poorly constructed and already, you know, not in good shape. So next we're going to look at an EF2 tornado. So EF2 tornado, you lose the leaves on your trees, tree branches fall off, you start getting enough wind force to push wood through wooden structures. Vehicles start getting significant damage to them, which I wasn't able to really simulate too well clearly here. Again, the windows lose a lot more shingles. Then you have EF3 damage. So EF3 damage, large trees overturn, you lose your roofs. It's enough force to put debris through the walls of your home, which is why you want to get into a basement or a centermost section of your home. Then we got EF4 damage. It's enough to cause significant damage. Your vehicles are overturned, your houses are destroyed, sheds and barns are gone. And then finally, the big one, the EF5, such as the Moore, Oklahoma tornado, well, you get the picture. Get underground. So with that concludes our weather training seminar. Thank you all for coming. Those that attended from start to finish will receive that certificate in your inbox. And those that might not have made it, or that were just here just for the educational purposes, thank you very much for attending. And we may have more of these events, so stay tuned to the Codex. And those that did sign up and that have been here from start to finish, you may not receive your certificate today, as everything has to get processed, but keep an eye on your inbox over the next day or two for an email that will come, and I'll try to make sure that my name is in there, Zero Cheese, and that it will show your that it's Skywarn certificate. It will come through as PDF format. So as long as you got Adobe or anything that can open a PDF, you can open it up, print it, and you're all set. So thank you for coming, and congratulations on becoming basic storm spotters. Welcome to Skywarn.